The year's 1962, and on a highway construction site outside Milwaukee, Wisconsin, the Poclain TY-45 hydraulic excavator demonstrates capabilities that cable-operated machines simply cannot match. With a 0.45 cubic meter bucket, 360-degree continuous rotation, and hydraulic cylinders controlling every movement with surgical precision, this French-designed machine represents a fundamental reimagining of excavation. The future of earth moving, proclaimed a 1962 Construction Equipment magazine review, marveling at cycle times 40% faster than comparable cable excavators. Yet even as American contractors watched the TY-45 work, few understood they were witnessing the death of an entire technology and the birth of the modern excavator. The hydraulic revolution would transform the industry completely within 15 years, making cable excavators obsolete and enriching the manufacturers who adopted it fastest. But the pioneers who proved hydraulics worked, small companies betting everything on unproven technology, would mostly vanish, their names erased by the giants who commoditized their innovations. In the aftermath of World War I, specifically 1919, a French mechanic named Georges Bataille established a small workshop in Chelles, near Paris, initially repairing agricultural equipment and manufacturing replacement parts for war-damaged machinery. The excavation industry at that time relied entirely on cable-operated systems, steam or diesel engines driving drums that wound steel cables to control bucket movement. These cable excavators, manufactured primarily by American companies like Bucyrus, Marion, and Northwest, dominated construction and mining operations globally. Cable systems were proven but fundamentally limited. Cables stretched under load, reducing precision. Drum mechanisms required constant adjustment, and the back-and-forth cable movement restricted digging patterns. Bataille recognized that hydraulic technology, already used in industrial presses and aircraft control systems, could theoretically replace cables if scaled appropriately and made reliable enough for continuous outdoor operation. His first experiments in the mid-1920s focused on hydraulic cylinders capable of generating forces sufficient to move excavator buckets. The workshop in Chelles smelled constantly of hydraulic oil and steel filings as Bataille and a small crew of mechanics fabricated prototype cylinders and tested various seal designs. Throughout the 1920s and 1930s, Bataille's workshop, operating under the name Société des Anciens Établissements Poclain, after merging with a local manufacturer in 1927, developed increasingly sophisticated hydraulic components. The company's first commercial success came not from excavators, but from hydraulic systems for agricultural equipment, specifically grape harvesters used in French vineyards. These applications provided revenue while Bataille refined hydraulic technology for heavier industrial use. By 1939, Poclain had developed a prototype hydraulic excavator, but World War II interrupted commercial development. The German occupation of France forced the company to manufacture components for the Wehrmacht, and Bataille's hydraulic excavator designs remained blueprints rather than production machines. After the war, France's reconstruction provided opportunities. The nation needed equipment to rebuild bombed infrastructure, clear debris, and construct new roads and buildings. Poclain resumed hydraulic excavator development in 1947, now led by Bataille's son Pierre, who had studied mechanical engineering and brought more systematic design approaches to the company's work. The post-war prototype, designated the Model H, featured a hydraulic swing mechanism but retained cables for bucket control, a hybrid approach reflecting uncertainty about hydraulic reliability. The breakthrough came in 1951 when Poclain introduced the TY, a fully hydraulic excavator with no cables whatsoever. Every function, swing, boom, stick, bucket, operated through hydraulic cylinders controlled by valves the operator manipulated from the cab. The machine weighed approximately 6 tons, featured a 0.25 cubic meter bucket, and could complete dig and dump cycles in roughly 12 seconds compared to 18 to 20 seconds for comparable cable excavators. French contractors testing the TY reported surprising results. The machine's precision allowed digging trenches to exact specifications without the over-digging common with cable systems, and hydraulic components required less maintenance than cable drums and sheaves. Smoother operation, less fatigue, noted one operator in Poclain's dealer testimonials. Yet skepticism persisted. Hydraulic systems were unproven in harsh job site conditions. Seal failures could disable the entire machine, and mechanics trained on cable excavators lacked hydraulic expertise. Poclain manufactured approximately 50 TY units between 1951 and 1954, selling primarily to French contractors willing to experiment with new technology. The company was proving a concept, not yet dominating a market. By the late 1950s, Poclain had refined its hydraulic excavator designs sufficiently to pursue international sales. The TY-45, introduced in 1958, represented the company's most ambitious model yet, a 12-ton excavator with a 0.45 cubic meter bucket designed to compete directly with cable excavators in the 10-15-ton class. The machine featured improved hydraulic pumps that reduced cycle times to under 10 seconds, and Poclain had solved early seal reliability problems through better materials and improved cylinder design. Critically, the TY-45 incorporated 360-degree continuous rotation, a capability impossible with cable systems that required operators to carefully manage cable wrap. This single feature transformed excavator utility, allowing operators to work efficiently around obstacles without repositioning the machine. Poclain began exporting TY-45 units to other European countries, and in 1960 shipped demonstration models to the United States. American contractors who witnessed the machines working expressed interest, but also concern. Poclain had virtually no dealer network in North America. Parts availability was uncertain, and the machines cost 15 to 20% more than equivalent cable excavators from established manufacturers like Northwest and Link Belt. The American market's response to hydraulic excavators evolved slowly between 1960 and 1965. Poclain established a small import operation in New York, but struggled to compete against manufacturers with extensive dealer networks and familiar service procedures. However, other companies were also developing hydraulic excavators, recognizing that Poclain had proven the technology viable. In Italy, Bruneri introduced hydraulic models in 1961. In Germany, Menck and Demag developed hydraulic excavators for that country's reconstruction boom. Most significantly, in the United States, several manufacturers began experimenting with hydraulic systems. Coring, a Milwaukee-based manufacturer known for concrete equipment and smaller excavators, introduced its first hydraulic excavator in 1963, the Model 505, a 20-ton machine with a 0.75 cubic meter bucket. Unlike Poclain's smaller machines, Coring targeted the heavy construction market where cable excavators still dominated. The 505 demonstrated that hydraulic technology could scale to larger equipment, and Coring's existing dealer network provided the service infrastructure that had limited Poclain's growth. By 1965, trade publications were regularly featuring articles about hydraulic excavators and the technology's advantages. Faster cycles, precise control, reduced maintenance were becoming widely recognized. The hydraulic excavator market accelerated dramatically between 1965 and 1970 as major manufacturers committed to the technology. Caterpillar, which had observed hydraulic excavator development cautiously, introduced its 225 hydraulic excavator in 1967, a deliberate response to growing contractor interest in hydraulic systems. John Deere followed in 1968 with its own hydraulic models. These giants possessed advantages that pioneers like Poclain and smaller manufacturers like Coring could never match. Comprehensive dealer networks spanning North America, parts distribution systems ensuring components reached job sites within days, and financial resources to subsidize aggressive pricing during market entry. The transition from cable to hydraulic technology accelerated brutally fast. Contractors who had resisted hydraulic excavators suddenly faced a market where cable machines were becoming obsolete. By 1970, virtually every major manufacturer offered hydraulic excavators, and production of new cable-operated excavators had essentially ceased. Poclain continued manufacturing in France and had established modest market share in Europe. But in North America, the world's largest construction equipment market, the company remained a minor player, overshadowed by manufacturers whose dealer networks provided the support infrastructure contractors demanded. Kering's experience illustrated the brutal dynamics facing hydraulic excavator pioneers. The company had successfully introduced hydraulic models and leveraged its existing dealer network to secure reasonable market share, manufacturing approximately 800 hydraulic excavators between 1963 and 1970. However, Caterpillar's entry fundamentally changed competitive dynamics. Caterpillar could offer comprehensive financing through its captive finance company, guarantee parts availability through its global distribution system, and provide trade-in values on customers' existing equipment that smaller manufacturers couldn't match. When contractors evaluated excavator purchases, total ownership costs increasingly mattered more than initial specifications. A coring excavator might perform as well as a comparable Caterpillar model, but if parts took 3 days to arrive versus same-day delivery from Caterpillar dealers, the productivity advantage disappeared. By 1971, Coring's excavator sales had declined 40% from their 1968 peak, despite the overall hydraulic excavator market growing rapidly. The company had proven hydraulic technology viable in heavy equipment, and the market reward was watching competitors with superior infrastructure capture the category. Engineering excellence alone couldn't overcome structural disadvantages in dealer networks and parts distribution. The recession of 1974-1975 devastated construction equipment manufacturers, exposed to narrow product lines and limited geographic diversification. Equipment orders collapsed as construction spending contracted sharply, and manufacturers with thin profit margins faced immediate crisis. Coring, which had invested heavily in excavator development while maintaining product lines in other equipment categories, saw its financial position deteriorate rapidly. The company's excavator division reported losses exceeding $8 million in 1975 alone. Poclain similarly struggled. The company had expanded manufacturing capacity in anticipation of continued growth and suddenly faced factories operating at 30% capacity with fixed costs that couldn't be reduced quickly enough. By 1976, both companies were exploring survival strategies, potential mergers, product line consolidations, or focusing on niche markets where competitive advantages remained. The hydraulic excavator market that had seemed so promising just years earlier had commoditized brutally, with established manufacturers using the recession to gain market share through aggressive pricing that smaller competitors couldn't sustain. By the late 1970s, the hydraulic excavator market had consolidated around a handful of dominant manufacturers. Caterpillar, John Deere, Case, and Komatsu controlled over 80% of North American sales. These companies had leveraged their existing dealer networks and financial resources to commoditize a technology that pioneers like Poclain had risked everything to develop. Kering attempted to survive by focusing on specialized excavator applications, introducing models designed for specific industries like pipeline construction and forestry. The strategy generated modest success. Certain contractors valued specialized features enough to accept Coring's limited dealer network, but couldn't reverse the company's declining market position. Poclain remained profitable in France and certain European markets, but never achieved significant North American presence. The company that had arguably invented the modern hydraulic excavator controlled less than 2% of the global market by 1980, its pioneering work generating profits primarily for competitors who had adopted hydraulic technology after Poclain proved it commercially viable. The 1980s brought further consolidation as financial pressures forced smaller manufacturers to exit the excavator market or accept acquisition by larger companies. Kering's construction equipment division was sold to Case in 1986, primarily for the company's wheel loader, and rough terrain crane product lines, the excavator business had become a liability rather than an asset. Poclain's excavator division merged with Case in 1974, though the company continued manufacturing hydraulic components independently. By 1990, the hydraulic excavator market had essentially completed its transition from pioneering innovation to mature commodity. Caterpillar and Komatsu dominated globally, with regional players like Volvo, Hitachi, and Hyundai holding significant market shares in specific geographies. The machines that contractors purchased bore little resemblance to Poclain's early TY models. Modern excavators featured sophisticated electronic controls, computer-optimized hydraulic systems, modern operator cabs with air conditioning and sound insulation, yet the fundamental architecture remained unchanged. Hydraulic cylinders controlled by operator inputs, replacing cables entirely. The last excavators manufactured under the Coring brand appeared in dealer lots in the early 1990s, though by then the machines were essentially Case excavators, with Coring badging for brand transition purposes. Finding an original Coring hydraulic excavator from the 1960s or 1970s became increasingly difficult. Most had been scrapped after years of hard use, their hydraulic components worn beyond economical repair. Poclain similarly faded from the excavator market, though the company's hydraulic components business thrived by supplying systems to various manufacturers. The pioneers who had proven hydraulic excavators could work, who had risked their companies on unproven technology and endured years of market skepticism, received no lasting recognition. Industry histories credited the hydraulic excavator revolution to the major manufacturers who had commoditized it, not to the small companies whose engineering had made it possible. Today, hydraulic excavators represent the default technology for excavation equipment globally, with annual production exceeding 500,000 units. Every manufacturer producing excavators, from industry giants like Caterpillar to emerging Chinese companies like Sany and XCMG, relies on hydraulic systems architecture descended directly from concepts Poclain and other pioneers developed in the 1950s and 1960s. The continuous 360-degree rotation of the joystick controls operating proportional hydraulic valves, the cylinder configurations controlling boom and bucket movement, all trace lineage to innovations those early companies proved viable. Yet outside equipment museums and collector circles, the pioneering companies' names are largely forgotten. Poclain exists today as a hydraulic system supplier, its excavator heritage unknown to most customers. Coring survives only as a brand occasionally resurrected for specialty products. The revolution they started enriched the competitors who learned from their engineering and leveraged superior market infrastructure to dominate the category. In equipment museums scattered across Europe and North America, a handful of early hydraulic excavators remain preserved: a Poclain TY45 in France, a Coring 505 in Wisconsin. Other models from manufacturers whose names meant something briefly before markets rendered them obsolete. These machines, with their relatively simple hydraulic systems and mechanical controls, seem primitive compared to modern excavators equipped with GPS, automatic grading systems, and hybrid powertrains. Yet the fundamental innovation they represented, replacing cables with hydraulics, proved more transformative than any subsequent advancement. The companies that pioneered this revolution demonstrated that great engineering creates categories but doesn't guarantee survival. Market infrastructure, dealer networks, parts distribution, and financial resources determine who profits from innovation. The machines that proved hydraulic excavators could work have mostly been scrapped. The technology they validated generates billions in annual revenue for manufacturers whose names appeared nowhere on those pioneering blueprints.